Until 1949, the western slopes of Australia's snowy mountains were known only to the hardy stockmen or dedicated fishermen. All this was to change with the coming of the Snowy Mountains scheme, with its two major diversions of the Snowy River to the west. The southern diversion, the Snowy Murray development, carries the waters through the range to drive the turbines of the Murray power stations. Between 1949 and 1961, as construction was proceeding on the projects of the northern diversion, the Snowy Tumut development, the investigation and design of the Murray projects was in progress. Bushmen and surveyors, engineers and geologists tracked into the mountains. Their tracks became roads over which hundreds of tons of equipment and materials were hauled to the site of what is to date the scheme's largest power station, Murray 1. By 1962, authority forces had cleared a wide path down the mile-long slope which would hold the three steel pressure pipelines conveying the water to the power station. Here would rise a building 520 feet long, 120 feet high and 75 feet wide, with a large glassed area on the western wall. Khancoban Creek was diverted, the main foundations excavated, the site was ready. Rapidly, the intricate pattern of wooden formwork grew as the contractors prepared the foundations for the draft tubes. These draft tubes convey the water discharge by the turbines into the tailwater bay. Steadily, the construction proceeded, bringing into reality the thousands of details conceived on the drawing boards of the authority's design engineers. Complex work drawing upon the skills of many professions. A generator pit under construction requires the skill of competent craftsmen to make its wooden molds. Soon, the formwork was stripped away to reveal the lines of the concrete superstructure rising from these foundations. As the foundations extended, bucket upon bucket of concrete was poured into position by crane. Like a gigantic jigsaw, components fabricated in many parts of Australia were lifted onto their footings, and Murray 1 began to take the shape previously seen only in the minds of its designers. In orderly progression, each section was completed. Concrete foundations, generator base, steel columns and glass wall with a double folded aluminium roof. Section by section, 75 feet wide, 120 feet high, until the southern portion of the building was ready for the electrical and mechanical installations. With the roof completed, the more specialized work within the power station was possible. Despite mud and slush, the next phase of construction commenced. The installation of 2 large overhead cranes, each capable of lifting up to 120 tons. This equipment was essential for the installation of the 10 vertical shaft turbines and generators, which would deliver nearly 1 million kilowatts of electricity when the station went into full operation. By 1964, the building had reached its full length of 520 feet, and the tempo of installation increased. Through the Victorian railhead at Khancoban came all heavy components. A 78-ton transformer caused excitement among local schoolchildren as the authorities' road transporter moved the equipment through the streets of Victorian. A journey of 25 miles was necessary to move all power station equipment over an intervening range into the Khancoban Valley, then into the mountains to the rapidly growing power station. Each of the 16 transformers to be supplied from Canada raised the voltage to 330,000 volts for transmission to Sydney and Melbourne. A turbine spiral casing made in Australia moves along the machine hall to be manipulated into position. This is an unusual operation, for the casing must be lowered vertically and then swung to a horizontal position before being lowered into its foundations. Concrete poured from the floor above and conveyed by chute surrounds the spiral casing. A solid foundation for a machine which can develop up to 160,000 horsepower from the water racing through the turbine at the rate of 5,000 gallons per second. Next in the installation sequence comes the turbine top cover. Followed by the intermediate shaft, which couples the turbine to the generator. This shaft has to be precisely aligned with the 95,000 kilowatt generator installed on the floor above. If necessary, it can be removed for overhauling of the turbine without disturbing the generator. At regular intervals, more components of equipment arrive. A planned sequence of supply which permits work to proceed smoothly and without delay. Here, a turbine inlet valve made in Australia with a bore of 5 feet 4 inches and weighing 55 tons is lifted into position. The opening of this valve allows the turbine to run, and when closed, it has to resist a total force of more than 1,000 tons from the water pressure in the pipeline. Throughout the station, a team of technicians string mile upon mile of cables and wiring, jointing, connecting, soldering and testing. Through the machine hall, a 240-ton generator rotor moves past the completed units undergoing their first tests. The noise of the opening inlet valve echoes through the power station, and within seconds full speed is reached. The first two units began commercial operation in April 1966, delivering peak load power to the interconnected electricity systems of New South Wales and Victoria. The remaining units were progressively commissioned over the following 15 months, and in July 1967 the last of the 10 units was ready for service, 8 months ahead of schedule.